We're gonna look at spheres, which is just three-dimensional circle, a ball. All right, set of all points in space equidistant from a given point. The great circle, and it'll hopefully make sense when we look at the diagram, is the intersection of a sphere and a plane that contains the center of the circle. All right, so if you took a ball, sphere, and you cut it in half, that flat part on the top is the great circle. All right, last thing is hemisphere is just one half of a sphere. All right, here are the diagrams of what everything looks like. What do the little dots mean right there? That's the back side that you can't see it. All right, if it's a three-dimensional thing, you can't see the back part of it, but that's what it's representing. All right, the first one is just what a sphere is going to look like when they draw it on worksheet or quiz, test, whatever. That's what it's going to look like. The great circle now is that circle that's right there. The flat part that would be right there if you cut it in half. And then you've got two hemispheres when you have a sphere, and cut it in half, you've got two parts, top and bottom. All right, here's you got all of the stuff that worked for circle, radius, diameter, chord, any of that stuff is going to be the exact same on a sphere. Sphere. So all of that stuff still works. You still got radius, you still got diameter, you still got chord. Any of that stuff is going to be the same. All right, first thing on spheres where we're going to actually do some work is surface area. Surface area would be the area on the outside of that sphere. All right, so all of the surface would be included in this surface area. Very simple formula, 4 pi r squared. That's almost the same thing as what? Pi r squared, which is what? But what is the pi r squared talking about? Area of a circle. So it's just area of a circle and got the 4 in front. That takes care of surface area for a sphere. All right, so if I did this first one right here, surface area is 4 pi r squared, 4 pi 4 squared. All right, so if I'm doing 4 pi 4 squared, I wind up with 201.1. All right, going to the next one, I'm going to do 4 pi r squared on that. Do I use the 9? No, because 9 is diameter, and this formula is calling for radius. So I'll do 9 divided by 2 and get 4.5. Plug that in.
That's 254.5.
254.5. For these, it's giving me the surface area and saying go back and find the radius. So I'm going to start with the surface area formula, and I'm going to plug in whatever number they give me for the S, the surface area. All right. Last time when it was just a circle, we had A equals pi r squared. What did we do with that? When it was A equals pi r squared, and I wanted to find R.
They did.
What did I do?
You put 4 pi for.
Well, I divided by pi the last time. So now I'm going to divide by 4 pi. And like I told y'all last time, if you do this as a fraction, you're okay. If you do it with the division button, the 4 pi has to be in parentheses or it's going to be wrong every time. All right, so what is 582 over 4 pi?
46.3. But that isn't your answer.
But that is r squared. And here's something that gave some of us trouble the last time. R squared is not the answer.
You have to square root it.
If I get r squared, I've got to square root that right there.
So R would equal
6.8. And so if it ever has the r squared in it, if it has the r squared in it, you're going to have to square root at the end. All right, so when I come over here, I'm going to start the same way. Plug in that 319. All right, what is 319 divided by 4 pi?
25.4.
And again, that equals r squared. So I'm going to square root that. Just 5.0. All right, but that is the radius, and it's asking for diameter.
Yes, sir.
So I would say 5 times 2 equals the diameter, my answer would be 10.
Yay.
All right, this one says find surface area for one hemisphere. So we're going to start and do the same thing. Surface area for the whole sphere. So this would be 4 pi 7 squared, and that answer is. All right, 615.8. Is that right? All right, so that's the whole sphere. Well, I don't want it. I want a hemisphere, which is half of that. So I'm going to take that 615.8 and divide by 2. You get 307.9. So if it asks for a hemisphere, the surface area, we're going to do the whole thing and then cut that answer in half. This one tells me the circumference is 12 pi feet. And that right there, a lot of times people overlook that. If it's got the pi in there, you're going to have to use it when we plug it into the formula. So make sure you pay attention to that. All right, well, if it's starting by telling me circumference and wanting me to find surface area, I know surface area is 4 pi r squared. So what do I have to plug into that formula? The radius. It gives me the circumference. Can I find the radius if it gives me circumference? Yes, because I know circumference is 2 pi r. So I go back to the circumference formula, use it. It told me circumference is 12 pi feet. So make sure you put the 12 pi in that spot. Not just 12. If you put 12, you're going to miss it. You got to put the 12 pi.
And then you divide 12 pi, or 2 pi.
I divide by 2 pi, and what happens?
It turns to 6 pi.
No, it does not. It turns into 6.
Oh, because
The pi's cancel each other out, and so you wind up with just 6. If you didn't have the 12 pi in there, you're going to get a completely different number, and that'll mess everything up. So now that I have my radius of 6, I plug that into the surface area formula. What is 4 pi 6 squared?
452.4. That's how to say it. That's how to do it.
All right, 452.4. Next thing is volume of a sphere. Volume is how much space it takes up, counting the inside part. Surface area was the outside part. Volume is everything. So I've got my 4/3 pi r cubed formula. All I need is to plug in the radius. This would be 4/3 pi 8 cubed. When we start getting cubes and stuff in there, the answer is going to be pretty big. So just go ahead and be prepared for that. Somebody tell me what this one is. 4/3 pi r cubed.
44.7.
All
Right. So when we start cubing, the numbers are going to be a lot bigger. So just be prepared for that when you're doing these. Don't be worried about it's in the thousands. That's going to be plenty of answers that way.
If it's in the
All right, if I had one like this where it gives me the diameter instead of the radius, what do I have to do first?
Divide the diameter by 2 to get
I've got to say 10 divided by 2 is 5 and say, okay, well, there's my radius.
and then plug
So
that.
then 4/3 pi 5 cubed winds up being
523.6.
523.6. This one is saying, here's the volume, go back and find the radius. Well, I'm going to start with the formula, and I'm going to plug in the number they give me for the volume. All right. What are we going to do next?
You're going to divide by 4/3 pi,
I'm going to divide by 4/3 pi.
and then you get 460.1.
Said 460.1.
Yeah.
All right. All right, from here, this is r to the third. So I've got to get it where it will do this on the calculator and give me the cube root. So click math 4, and it should pop that up where you see the cube root.
And write that in your notes, math 4.
Math 4 is what will get you to the cube root. So I've got to do the cube root of 460.3, which winds up being somebody
7.7.
so make sure we understand how to get to that cube root. Now, the only time I'm going to use this is when it's got r to the third in the problem. So I'm talking about a volume situation. If it's a volume problem, I'm going to have to do the cube root down here for the last step. Start by plugging in the volume that they give me. What's my next step?
Then you're gonna get 14.
Well,
Yeah.
divide by 4/3 pi. 214?
Yeah, r cubed.
All right, so that's r to the third.
And then
The cube root of
after
that.
that, you're gonna get 6.
So I wind up with 6 for r, but that's not what it's asking me for. It's asking me for diameter and
For
circumference.
diameter, you multiply that times 2.
The diameter would be 2 times r, 2 times 6, which is
And then
12.
for circumference, you're gonna plug it in. Into that's 30, yeah.
All right, so if I want to find the surface area and volume for each one of these, the first one has a radius of 3, so I'll go 4 pi 3 squared. How much is that?
113.1.
All right. And the second volume would be 4/3 pi r cubed, and it just happens to be the same thing. That's not going to happen very often. Go to the second sphere, and it says 4 pi 6 squared when I plug in that radius and get 452.4. And then over here it would be 4/3 pi 6 cubed 9.
94.88.
All right. It says find the surface area and volume for each. What it's going to have on the EOCT or whatever is to compare the two. If I wanted to compare the surface area, I would take the second one and divide it by the first one. And that'll tell me how much bigger or smaller it is. So what is 452.4 divided by 113.1?
Four.
So this one is 4 times bigger. And then if I go for the volume and do the same process, the second one is 904.8, 113.1,
8.
8 times bigger. So that's all you're doing is how much bigger or smaller is the second one compared to the first one. All right. I'm going to show you a way to do this. Well, let's go ahead and do it. You can do this without doing the work. You can get rid of all of this stuff in here and not have to do it. The way to do it is this. I'm going to take the second radius and divide it by the first radius. So always the second divided by the first. That tells me as far as the ratio goes for the radius is 2 times bigger. For every surface area or any area problem period, we always square. What is 2 squared?
4.
4 times bigger. For every volume problem, you always cube it. What is 2 cubed? 8 times bigger. So find the radius, square the radius talks about surface area, cube the radius talks about the volume. So you should be able to look at the problem and get straight to the answer down there of 4 times bigger and 8 times bigger. All right, do that one. All right, doing the shortcut version, I'm going to say, well, 12 divided by 4 is 3. So the radius is 3 times bigger. For surface area, that means 3 squared or 9 times bigger. And then for the volume, it's 3 cubed, which is 27 times bigger. Is there any problem with that? All right, do this last one up here. All right, so if I'm doing this one, what's obviously happening with the radius? Got smaller. When I compare the two, the radius is 1/4 as big. So for surface area, I'm going to take that 1/4 and square it, which means
116.
what's 16th as big, or another way of saying it would be 16 times smaller, whichever way you want to do it. Volume would be 1/4 cubed, which would be 1/64, as big or 64 times smaller. Again, whichever way you like.